Now our link model is the one that we want to add Base62 to. But first, we should really just implement Base62 as a feature. So we're going to go into our app models folder and make a base62.rb file. And we will define base62 in here with two methods, two class methods. So we can call encode, and it will take a number and spit out a string. And we'll call decode, which will take a string, should be in class method, and it will spit out a number. So we'll go and have two ways of interacting with this. We'll say encode, say 1024, and then we'll base62 decode something like this, GW, or some random characters. As long as they're alphanumeric, we can convert that string into a number. And this is how we're going to implement Base62. But because this is kind of an algorithm that we need to implement, we're going to spend time writing tests for this. So we'll go into test, we'll go into models, and we will copy this link test, and we will rename it to base62 test.rb. All right. Now we'll change the name of this link test to base62 test, and we can define a few tests that try to convert or encode and decode our numbers. So let's think about how we want to do this. So we need to come up with examples of how we want to encode numbers. So if we say here, encode the number 0, we might want one that encodes, let me just copy this a few times. We want to test that it encodes the number 1 correctly, and then we can start testing some other examples. So whenever we get past the integers, if we assume we start with those integers 0 through 9, then when we get to the number 10, we should expect that it encodes to a different value. So what we want to do here is assert equal that when we encode base62 encode the number 0, we want the string of 0 back, assuming that our alphabet starts with 0 through 9. Then for number 1, we want to encode that to number 1. Then for 10, in base 10, we want this to be encoded to either capital A or lowercase a, which I'm going to do lowercase, and that is going to be the result here of encoding that number. And we want to give some other examples here so that we can tell that, this has encoded to the correct value. So with base62, if we were to give it the number 62, if 0 is our first number, then base62 of base62 is actually going to add an additional character here. So it will end up with the string of 10. So it will wrap around because we've already used all 62 values. So this is going to wrap around. We're going to end up having to add a character at the beginning, just like you do with 0 through 9. When you get past 9, you have to start and add another character, 1, 0. And then when you get to 99, you have to do 1, 0, 0, and you reset. And it's the same with binary, base 10, all of these things. You just define an alphabet that you're going to work with. So we can put some other numbers in here as well to test with. We want to encode something random like 1024. We can assert equal this value. And if we do the math, I've already done this, that is GW, base62 encode 1024. And then we can do some large number like 99999. And this one, I happen to know, comes out to 4C91. And we'll do the math and I'll show you how all this works. But we'll write some tests like this so that we can have some expected inputs and outputs. And then we can run our test suite and say Rails test, test models, base62 test. And all these tests should fail. Lots of red. 6 assertions, 6 failures. So everything is failing, which is not ideal. But you know what? Here we are at the beginning, and we have no code. So in order to implement Base62 encoding, we need to start with having an alphabet. So we're going to say, here's our alphabet. This is 1, 2, 3, 4, 5, 6, 7, 8, 9. Then we start with the lowercase numbers, A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, and Z. Then we also add A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, and Z. Then we can also tell Ruby, let's freeze the string so it can't be changed. And our base, which will be useful, is the length of the alphabet. So one cool thing about this is that this could actually be used for anything. So you could add lots more characters to this, like hyphens and things, and it wouldn't be necessarily called Base62. And so maybe a better name for this is a shortcode class, which takes this alphabet, which you could add characters to in the future if you wanted. You'd have to make sure that you don't break the old URLs or anything if you were going to change this alphabet. But really, maybe the better name is shortcode, even though technically we're implementing Base62. But for now, this is what we're going to do. And we can hop into the Rails console and look at Base62's alphabet, and we can look at the base that tells us, yes, we do have 62 characters here, and that's good. So that will give us everything we need to start working on our encoding. So how does this work? Well, if we go through the number that you give us, we want to go through and have that pass our tests kind of as quickly as possible. So the easiest might be to just have this return 0. And then we can run our Rails tests, and we see one of our tests passes now. So we have 5 failures, 6 assertions though. So we've made one of our tests pass. This one passes, but everything else is broken. And this is kind of the process that you do with TDD. You write your tests, inputs and outputs that you expect, and then you just do the bare minimum to implement a feature here that passes a test. And then you work on the next test. So then you might say, well, if number is 1, then we want this to be 1. Otherwise, we want it to be 0. And you do some really basic kind of dumb code to make your test pass. But we're getting there. We have 4 failures now and 6 assertions. And we start working on this until we get to a point where you actually have to implement the Base62 algorithm. So what are we really doing here? Let's back up and let's say we're really trying to build a string and return that value. So here is where we could say result plus equals that character of 0 or 1 or whatever the number is. And we could say result plus equals the number to string. And if we do that, we are going to get the same 4 failures and 6 assertions. So these, where we have added things that are above the 0 through 9, like A, or 10 actually, should be converted to A. So now we've got to start looking at, okay, well, this is a little naive, but it does work for these first items, where you just take the number, give it back to you, and it matches. So with Base62, the real implementation that we want in between here is we want to look through this number, and while the number is greater than 0, we want to do some stuff. We want to take this number, and let's put a good example in here, like that 1024. This is a big number, and we want to basically divide it by the base of 62 and say, how many times does 62 go into that, and what's the remainder? So here we want to get the remainder of how many times 62 can be divided into 1024. That will be used for the positions that we add. And the remainder is what character we want to display here. So let's look at this. If we were to do 1024 divided by 62, it goes in 16 times 0.516129, a lot. So what we can do is we can get the remainder and say 62 times 16, and we get 32. 32 is the index of the alphabet we want to go grab. So we can do that by getting the remainder. So we'll say, oops, not there. The remainder is going to be the number percent 62. So that's using modulus to get the remainder of, if you divide this number by 62, what is the remainder left over? That remainder is actually going to be the index of the alphabet that we want to grab. So a character at that position. So we will say result prepend the alphabet index. And if you want, you can say, let's just assign this to a character and say, we'll prepend that character. And then our number is going to be the number divided by 62. So this is going to then say, okay, first iteration, we'll divide 1024 by 62. It goes in 16 times, so we'll subtract 62 times 16. So we get 32. So our index is 32. The character at position 32 is, this is position 1. Treat it like an array starting with 0. This is index 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's why all those numbers match up. Then we have 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. And that's a W. So our character ends up being W, and then we take the result and we prepend that. So our result ends up being W. Then our number becomes 1024 minus 62, or rather just divided by 62. And that's going to be integer division. So we're going to end up with, if you do this in Ruby, you'll see it a little bit easier. Say 1024 divided by 62. So you'll see our remainder is 16, or our times that it goes in is 16. And it just truncates all of the decimal places because we're doing integer division in Ruby here. So then we get 16. And then the next iteration is, okay, our number is greater than 0. So then our index becomes number modulus 62. And because it's less than 62, the index will be just the number itself. Then our character will end up being character number 16, or index of 16. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So our character is G. We're going to prepend that. So the result is GW. And then our number is 16. We'll do IRB again. 16 divided by 62. Because it's less, 62 doesn't go into 16 at all. So the answer is 0. And our number is 0. And we start the loop over again. While number is 0, we do this. But now it's 0 and we're done. And we can give that result back, which is GW. So that's how you convert a number from one base system to the other. In our case, we have 62, and because this is a constant, we can go up there and use this. So if we did rename this to shortcode, I'm going to do that. You know what? Let's just do it. Shortcode.rb, and then our Base62 test should become, let's go through here, Base62, shortcode, boom, and then rename our test file. Shortcode test. Perfect. All right. So anyways, that is now going to allow us to encode all of these numbers properly. And if we run our test file, now that we've renamed it, shortcode test, all of our tests pass except for one. And this one's special because if you look at our code, if we gave you the number of 0, we'll start with an empty string. We'd look and say, hey, is your number greater than 0? Well, no, because you gave us 0. So we're going to give you an empty string back. So 0 ends up being a special thing here. And we'll say if number is 0, we will just return 0. Another thing that we could do is also check and see if number is nil. And we could say, let's return 0 in that case as well. Because in Ruby, If you say nil, convert that to an integer, it is going to give you back 0. So that will make this consistent where we get the first character in our alphabet like so. And to make this a little bit more dynamic, we'll say alphabet dot first instead of hard coding that 0 in there. So in case you want to do this in a different order, for example, maybe you want to move these to the end, what you would have to do is change your tests to match because the first character would now be an A. And if we look at this in the Rails console, we can say shortcode.encode 0. Oops, that should be an integer. We'll get A now. And if we give it 1024, we'll get QG, Q capital G. And that is basically just shifting the alphabet around so that we have that like so. But it's really convenient to have the integers at the beginning so that 0 maps to 0, 9 maps to 9. And then once we get past base 10, then we can start adding these alphabet characters afterwards. So it's pretty cool, right? So now our tests are all passing. I want to run them once more, and we can commit this and add. We'll say git add dot to add both of these files, and we'll commit and say add shortcode Base62 encoding. All right. So now in the next lesson, we can add tests to go the opposite direction, where we'll take the shortcode of GW and go back to the number 1024. And we'll explain how to do that as well.